Okay, here when I see it very carefully, the path chosen by the author is SABT. Now, if I select S to A to B, but there is no path from B to T because it is a reverse edge. You can see the direction of the edge is B to T, which definitely means that the reference that we have taken from somewhere is giving it wrong. So what should have been the actual path? The actual path should have been S to A to B to D, and possibly T. This could have been one more path. So it is possible to take this path also, because this reverse edge gives you an option of reversing the order. So if I take this one, S to A, S to B, and then there is a edge from B to D, which is this one is a reverse edge. As you can see, this one is the 7. So 7 is remaining, and the 9 is remaining in the next also. I repeat this one. If we select the S to A to B, B to D and T. So one is this, second is this, third is this, and the fourth is this. Just check the minimum bottleneck capacity. First edge is 10, second is 5, third is 7, and the fourth is 9. That means the residual capacity is or the bottleneck capacity is 5. तो हम लोग 5 प्रोड्यूस कर सकते हैं, लेकिन ये वाली एज को सेलेक्ट नहीं कर सकते हैं बिकॉज इट इज इन द रिवर्स. I hope this is understood by all. Rather than going for this, we should go for this SABTT. अब जब हम लोग इसको रीड्रॉ करेंगे तो what will the S2A become? S2A इसकी रिमेनिंग कैपेसिटी 5 हो जाएगी और इसकी जो रिवर्स एज है वो भी 5 हो जाएगी. अब A to B, अब ये जो A to B है, this will become रिवर्स एज 5 बिकॉज कैपेसिटी खाली हो गई. अब B to D, पहले कैपेसिटी 7 थी, अब ये कम होकर 2 रह जाएगी और रिवर्स 1 से बढ़कर 6 हो जाएगी. एंड द लास्ट इज D to T, पहले कैपेसिटी 9 बची हुई थी, अब कैपेसिटी 4 रह गई है, रिवर्स की 1 से बढ़कर 6 हो गई है. दैट इज T. I hope that this is clear. So there is no difference in the answer. हमारा फ्लो 5 से ही बड़ा है, लेकिन हमने जो पाथ सिलेक्ट किया था वो पाथ हमारा गलत हो गया है. सिमिलरली हम लोग इसी चीज को आगे देखते हैं इन द नेक्स्ट वन. तो लेट्स जस्ट मूव डाउन इनटू द लास्ट वन. So this is the one that we have decided, and this is the next one. This one is correct. So this one is absolutely correct. I will just remove the annotations from here. So this one is correct. We can grow from S to A, and then from A we can come down to C. Then we can go to T, and then we can go to D. This is correct. This is correct. But the graph will be different. The graph will be different, but this one is correct. So what is the maximum flow that we are going to get is 15. But this is not the correct graph that is being shown to you. So that will be slightly different from the one given in here and the one we have computed. So I hope you will consider that thing, that there is now no path from B to D. As you can see, अगर आपको S to A to B और B से अगर T जाना है तो आपको B से नीचे D तक आते हुए T पर जाना पड़ेगा. So students, in the last lecture, while we were solving this, I found that there was some directional issue. in the edge. So I came back to just explain that you cannot go directly from B to T, but you have to come down from B to D and then go from D to T. So I think this is very clear to everyone. So as far as the time complexity of this algorithm goes, there are so many algorithms that are available. So there is no one specific, you can say, complexity related to this algorithm. So the whichever, if you want to follow the depth first search, you want to follow the Ferguson, this one. So Ford's algorithm, the complexity will surely depend upon which type of algorithm that you have decided to follow. So I will just detail out what is the different capacities or the different complexities that exist for these algorithms. You can please note them down. So I am just going to tell you the various complexities that we have available with us. If we are following the depth first search technique, I repeat, for the depth first search technique for finding all the augmented paths. Augmented paths क्या है? अगर हम start से लेकर end तक जाते हैं, अगर हम start से लेकर end तक हर path को ढूंढते हैं, that is called the augmented path. And what is the capacity if you are using, or sorry, what is the complexity if you are using the depth first search? The complexity is big O of FE. I repeat, big O of FE. This will be available in the final notes whenever I share. So there are many other algorithms given by the Edmonds-Karp. The algorithm has been given by the Ford-Fulkerson. ठीक है, तो फोर्ड फुल्करसन हमें जो एल्गोरिथम देता है उसकी कॉम्प्लेक्सिटी कितनी है? E square into log of U. Then there is Dinnick's algorithm. The complexity is V square of E. There is a push relabel algorithm, जिसकी capacity is also V square to E. So you please note down the different capacities so that when you give the answer, you are able to tell what is the complexity of this particular algorithm. Now, whether the algorithm has been given or not, if we go by the this notes, there the steps have been given and the actual algorithm has also been given. This is not a deterministic algorithm. This is just the steps that have been given, that this is how we are going to solve it. So what is the first step? The first step is to initialize the flow to all the nodes. Initialize the flow for each edge is equal to 0. ये हमने किया था, हमने हर edge का flow 0 कर दिया था. उसके बाद हमें augmented path find out करना है between S to T in the residual graph. Original graph में path find out नहीं करना है आपने residual graph में path find out करना है कि if there exists any path from S to T. अगर exist करता है तो हम लोग augmented flow को अपडेट करेंगे, augmented flow को अपडेट करेंगे और उस flow को हम लोग कंसिडर करेंगे into the final you can say solution. शायद एक टर्म हमने किया है लेकिन आपने उसका मीनिंग नहीं समझा, दैट इज अपडेटिंग द ऑगमेंटेड फ्लो या अपडेटिंग द रेजिडुअल नेटवर्क ग्राफ. ये ऑगमेंटेड फ्लो या रेजिडुअल ग्राफ को अपडेट करना क्या होता है, जैसा मैंने आपको बताया था. I'll just give you one more example of the same. अगर आपके पास A to B है, then capacity is 10. The original flow is 0. अगर आप इस पाथ से फ्लो पास करना चाहते हैं 2, तो what is the meaning of updating the residual network graph या updated the augmented flow का मतलब क्या है? This 0 will be turned into 2. इसका मतलब क्या है कि आप 2 यहां से पास कर रहे हैं. What is so the remaining capacity becomes 8 and how much flow you are using is 2. अगर आप 3 का फ्लो और भेज रहे हैं इस पाथ से, then the remaining capacity will become 5 and the residual edge will also become 5. This is called the updating of the residual graph. I hope we have taken a lot of time today. This was a pretty typical topic, so I wanted that you all get a good idea of this. All the terms have been explained very carefully. I have not hurried up from any term. मैंने कोई term मिस नहीं किया है, बहुत ध्यान से सारी terms आपको बताई हैं. फिर हमने फ्लो नेटवर्क का एग्जांपल देखा, हाउ टू कंप्यूट द मैक्सिमम फ्लो, उसका भी बहुत आराम से एक एग्जांपल देखा है. और in the end, this is the algorithm that is used to compute the maximum flow, and this algorithm is given by Ford Fulkerson. So this is the end of the lecture.